Hello. Today we're going to start chapter 8, and we have two sections in chapter 8. We have 8.2 and 8.6. 8.2 is derivatives of two variable functions, and 8.6 is antiderivatives. So we're going to start with 8.6 since we're used to doing antiderivatives, and then we'll go and I'll post a video about derivatives, and that's it. So this begins test 4 material, and here we go. I hope everybody's doing well, and that you're practicing your social distancing and getting out and getting some exercise and taking walks and calling your folks. Okay. All right, so here we go. So chapter 8 is multivariable functions. And really, we're just going to do two variable functions. Okay, so 8.6 is double integration, double integrals. Okay, so okay, and maybe that helps. All right, so, and double integrals, we'll talk about those in a minute. All right, so when I talk about two variable functions, we're going to have x's and y's instead of integrating a function that looks like 3x plus 4 with respect to x, okay? And this is going to be, it has x's and y's in it. So let's just review though. Let's just kind of review my 6.1 rules, because those are the rules that we're using. But it's kind of weird because you have x's and y's. So we're used to having x's and constants or y's and constants, but not both together, okay? So when I integrate with respect to x, this is telling me that I'm going to use my rules with respect to x. So for integration, that tells me I'm like increasing each term by x. Like derivatives, decrease, d and d. And antiderivatives, you add, okay? Or if you do an integral, you increase, okay? So remember our 6.1 rules, okay? And the ones that we'll use, if I integrate some constant with respect to x, okay? So a constant means just a number. So I'm increasing that by x. It's going to be kx plus c, okay? All right, so I'm going to keep saying this over and over. This is a constant, okay? All right, and I'll tell you why in just a minute. And if I have an integral of a constant times x to a power, what do? I bring over my constant, okay? And then I just integrate the x term. So what do? I add 1 and divide, plus c, okay? All right, and then unless my exponent is what? -1, and then I'm going to, if I have k over x dx, and then I rewrite that as kx to the -1 dx, then when I try to add 1, I get 0 for my new exponent. So I can't have 0 divided by 0, so that tells me that this is rule 3. Okay, so that's bring over my constant. It's a ln of x plus c. Okay, all right. So these are the rules that we're going to use. Okay, and so let's do what I wrote earlier. If I integrate 3x plus 4 with respect to x, okay, that means I'm increasing each term by x. So really, to integrate 3x, I bring over my 3, right? And I just integrate the variable term. So when I add 1 to the exponent, I get x squared over 2, okay? And so that's rule 2. And then plus, when I integrate a constant, I just increase it by the variable. So that's just plus 4x plus c. Okay, and you're like, duh, I already know all this. Well, it's important to know when we integrate with respect to x, x is my variable term. And sometimes I'll integrate with respect to y, and y will be my variable term. So let's talk about this. So when I integrate two variable term with respect to x, okay, I'm going to treat x as my variable term, but I'm treating y as a constant term. So y will just look like this sometimes, a constant term. And how do I integrate a constant term with respect to x? Well, I just bring over my constant and I increase it by x. All right, so sometimes we'll have to look at y's and treat them like a constant. So when I integrate, this tells me what I integrate with respect to. So I'm going to integrate with respect to x. Okay, and that I have to treat y as a constant, or y as a number, okay? And so sometimes with y, we'll use rule 1. Okay, let me just show you what I'm talking about before we start the double integrals. So let's say I have this, the integral from -1 to 2, and I have 4x plus 3y, and want to integrate it with respect to x, okay? So this is very important right here. This tells me that x is my variable term. Okay, but I have to variable. All right, but then I have to treat y as a constant term. Okay. All right, so if I integrate 4x with respect to x, that's just normal, okay? So that's going to be my antiderivative, it's really f of xy, is 4x squared over 2, normal, normal, normal. Okay, plus when I integrate 3y with respect to x, so when I integrate with respect to x, I have to treat y as a constant term. So I have to go here and go, how do I integrate a constant term with respect to x? Well, I just increase it by x. So if I integrate 3y with respect to x, that's just 3yx. Okay, that's what's a little weird. It's called it's like light bulb mathematics. Once you see it, you see it. Okay, so then I have to evaluate it from -1 to 2. And this is where it just gets sometimes a little tedious, okay? So I make my parentheses. So what am I doing? Remember, I'm integrating with respect to x. So that means I'm plugging in for x. Okay, so when I plug 2 in for x, I get 2 squared is 4. 4 times 4 is 16, and 16 over 2 is 8. Plus, and when I plug in 2 for x, I get 2 times 3 is 6y. So when I integrate with respect to x, my x's are going to be plugged into, and then I'm going to be left with y's. So now let's take -1 and plug it in for x. Okay, so -1 squared is 1, okay? And then 4/2, that's just 2. And then I'm going to plug -1 in for x. So -1 times 3y is -3y. So that's what I'm talking about right here. We're kind of used to using our calculators, and you can use your calculator, but I just want you to be able to go, okay, -1 times 3 is -3y. So, but don't forget, you have to distribute your negative here. And combine like terms. So I have 8 plus 6y. Okay, minus 2 plus 3y. So I'm left with 9y plus 6. Okay, all right. And when I do my double integrals, I'm going to integrate this with respect to y, and it's just going to be normal. Okay, this first step is the one that's always going to have the two variables in it. So you just have to be really careful. The second integral is going to be just like using your straight up 6.1 rules. I integrate a y term with respect to y or an x term with respect to x. Okay, so let's go try one more, and when we integrate with respect to y, okay? And then we'll do our homework. We'll do all the problems in the homework. So if I integrate a two variable function with respect to y, okay, and this is how I know, I always have to look there. I'm integrating with respect to y, and that means I'm going to treat y as my variable term, but I have to do that weird thing and treat x as a constant term. And that's what is weird. That's why I have to, that's why when I wrote down my rules, I have to say this is a constant with respect to x, so I increase it by x. If I have a constant times x, I bring my constant over and I integrate the x term because I'm with respect to x. Does that make sense? I'll do this over and over. So let's do another example. Let's say from -3 to 4, and I have 5x minus 2y, and I'm going to integrate it with respect to y. Okay, so in my head, I have to go, okay, so y is the variable term, and x is treated as a constant. Okay, and so how do I integrate a constant term with respect to y? Well, that's rule 1. If I integrate a constant term with respect to y, what do? I just increase that constant term by y, okay? And your constant term might not always be a number. So if I'm integrating with respect to y, I always just circle, like say, there's my variable term. So 5x is just going to be 5xy because 5x is constant. So to integrate a constant term with respect to y, I just increase it by y. Minus, if I integrate a y term with respect to y, it's just normal. That's just 2y squared over 2. And I could call that 5xy minus y squared. You can simplify or not simplify. Okay, and to me, this is the hardest part. It's not hard, it's tedious. All right, so I'm going to make my two parentheses, and since I'm integrating with respect to y, I'm going to plug my numbers in to y. Okay, so if I plug 4 times 5 is 20x minus, if 4 squared is 16. Okay, and then I'm going to take my -3 and I'm going to plug it in for y. Okay, and you have to be careful. All right, so -3 times 5 is -15x, but minus -3 squared, if you have to put that in your calculator, if you put it in as -3 squared, it's going to be -9, and that's not true. If you're squaring -3, you have to put it in your calculator like that, okay? All right, so -3 squared is 9. Okay, so now, again, I distribute my negative and combine like terms. So up 20x minus 16 remains the same. So it's plus 15x plus 9. So I end up with 35x and -16 plus 9. Y'all, I'm so sad. I know that's -16 plus 9 is -7. Okay, so when I integrate a two-variable function with respect to y, I'm going to be left with x's. And so when I get to my double integrals, I'm going to integrate that with respect to x, so it'll just be normal. Okay, so I think we should just get started. Okay, all right, so we can do this. It's tedious, okay, and this is where it's going to be really important for you to write everything down. Okay, I'm going to need to see all your work. Remember, you're submitting all of your work into Blackboard, and that way you can get partial credit. Okay, if there is no work, there's no credit. Okay, all right, so I wrote your homework problems down. Here they are. And so, when we integrated what's it called? Continuous function on the interval AB, we were finding the area if the function lied above the x-axis. And now, if we're doing a double integral, we're really trying to find the volume of a solid, but it never talks about that. We don't have to, I mean, we don't talk about that in our homework, or we don't have to do anything really complicated with volume. So here we go. This is problem number 1 in your practice problems. So from -4, I picked out the one, I made them have hard limits so that we, -1 to 2 of x plus y, and this, oh, I'm so sorry. I'm gonna just forget about that. I'm not stopping my video. -4 to -2, and then 1 to 2, so 8.6, this is problem number 1, and then x plus 12, and then dy dx. Okay, so, and dy dx, dy doesn't always come first, sometimes dx comes first. You just have to look. So when I do a double integral, what I'm going to do is I'm going to work the inside first. And this will be the only time you have two variables, okay? So in the end, I'm going to be left with, I'm going to go here, and I'm going to integrate from 1 to 2, x plus 12 dy. Okay, all right, and so after I do that, I'm going to be left with the integral from -4 to -2 with my answer with respect to x. Okay, that's a little sloppy, but I'm going to go work the inside first. Okay, so if I'm integrating x plus 12 with respect to y, what does that mean? That means y is variable, x is constant. Okay, so the integral of x with respect to y, so x is a constant term, so that's just x times y, okay, and then plus 12 with respect to y, that is just a normal, that's just 12y, okay. So remember, in my 6.1 rules, wherever they are, I just go back to my rules. If I integrate a constant with respect to y, I'm just increasing that constant by y plus c. So when I'm integrating x with respect to y, x is a constant, so it's xy, then 12y. So now I evaluate it from 1 to 2, and then this is where you got to be careful and write neatly. So remember, because I'm integrating with respect to y, I'm plugging in my limits for y. Okay, so 2x plus 12 times 2 minus, and I plug in 1 for y, so 1x plus 12, and then I distribute my negative, and get x plus 12. You don't always get what you start with, okay, but we just happen to do that in this. So now I'm going to integrate x plus 12. So this is now my x plus 12. So I'm going to integrate that from -4 to -2 with respect to x. And so it's just normal. So now I'm doing the outside. Whatever I got for the inside, I'm going to do it from -4 to -2 with respect to x. Okay, and that was my answer that I got. Okay, so this is just 6.1. And my antiderivative of x is x squared over 2 plus 12x. From -4 to -2, So f of -2 minus f of -4. And y'all know that once I get here, I can use my calculator. So I'm going to store -2 for x, so I can plug it in here. They don't take decimals, so you have to make everything be a fraction. So I say -2 store for x and enter. And then I plug in my antiderivative, x squared divided by 2 plus 12x. Okay, there's my X button. There's my store button. Okay, and then I enter, and it's -22. Okay, and then -4. I'm going to go -4 and store that for X and enter. And I'm going to go up and highlight my antiderivative and push enter twice, and I get -40. And so, you know me, I'm so lazy, I'm going to go up and highlight my -2 so I don't make any mistakes and push enter, minus, and I go up and highlight my -40 and I push enter again and I get 18. And that's my answer. That's why it's so important to see your work, because if you just put 12, it's all wrong. But if I can see your work uploaded to Blackboard, I can go, oh, you got it right until this point right here, you know, and so I can give you partial credit. So, okay. Or Mr. Hunt or Mr. Aslan or Ms. Newsom will give you partial credit. We're all doing the same thing. Okay, so that was number 1. And you'll be very excited to hear there are only 5 problems. And really, I did one twice so that we could just get some more practice. Okay. All right, so let's do it. Okay, number 2 in the practice problems. So the integral from -4 to -2, again, they're not always that, and 5 to 7. And then I have -x minus 15y. And it's dx dy this time. This is random order. You never know if you're going to integrate with respect to x or with respect to y first. So I'm going to draw a rectangle about my inside, around the inside, and I'm going to go work the integral from -4 to -2 with respect to x. Okay, and then I'm going to be left over with the y's with respect to y at the end. I'm going to put whatever I get in there. Okay, so let's go look at this, because this is kind of this is the new part. All right, so I'm integrating with respect to x. So what does that tell me? I'm going to increase each term by x. That's what it's telling me. X is a variable term and y is a constant term. So -x with respect to x will be -x squared over 2, and minus 15y with respect to x. Well, 15y, so x is variable and y is constant with respect to x. And so how do I integrate -15y with respect to x? It's just -15yx. Okay? I just increase each term by x. If you do an x term with respect to x, it's like normal. If you do -15y with respect to x, that's just a constant term, so you just increase it by x. Okay, all right. So from -4 to -2, and this is very tedious. Okay, so what am I plugging in for? X. So I take my -2 and I'm going to plug it in for x. And I take my -2 and plug it in for x. So -2 squared is 4. I'm not squaring this negative. Okay, so -2 squared is 4. So it's -4 over 2, which is -2. And -2, if I plug it in for x, -2 times -15 is plus 30y. Okay. And then I'm going to take -4 and plug it in for x. So -4 squared is 16. So it's -16 over 2 is -8. And -4 times -15 is positive 60y. Okay, that's where I mess up because I can't completely use my calculator because I have two variables. So, but I can always say, well, you know, negative, if I were going to plug that into my calculator, it would be a negative, you can't really say that, a negative, -2 squared divided by 2 and get -2. And then minus 15y times -2 is 30y. So, I mean, you can do it however you want to do it. But remember, now we've got to distribute the negative and combine like terms. So it's plus 8 minus 60y. So I get negative 30y plus 6. Okay. And now that's what I have. And I'm going to put negative 30y plus 6 and integrate it with respect to y with these outside limits. Okay, so I'm going to just go down here and do from -4 to -2, negative 30y plus 6 with respect to y. And this is just one variable with respect to y, so it's normal. And so my antiderivative with respect to y is negative 30y squared over 2 plus 6y from -4 to -2. So once I get to the end, I like it because I can use my calculator. And even though it's y, I'm plugging in for x. So -2, -2, store for x and enter. And I'm doing -15y squared, or you can do it 15x squared plus 6x. And that gives me -72. And then I'm going to do -4, store for x and enter. And then I'm going to go up and highlight my antiderivative. Get -264. So I'm so lazy, I go up and I highlight my -72 minus the -264. And I get 192. Okay, and if that x and y stuff just freaks you out right here, you can say -2 store for y, and you could just push the x button twice, and it stores it for y. And you could put -15, and you just push the x button twice, y squared plus 6, and push the x button twice, and do it that way if you want to use your y's. But okay, all right, so now here we go. I'm going to skip number 3 that's in your practice problems because I want to save it to the end. I'm going to do number 4 and number 5. And there's really just one of these, but they're longer and they're tedious, so I thought I would just work through a couple. So from 5 to 7 and 3 to 6, well, there are 2 of them in your homework. So -9x plus 18y minus 19 dx dy. And again, dx dy is just random. You don't know what's coming first. So we're just going to draw a rectangle around the inside and go work that from 3 to 6, -9x plus 18y minus 19. And we're going to integrate it with respect to x first. So that means x is my variable term and y is constant. And when I say x is variable, that means I'm increasing by x. I know that's not really true. X squared over 2 or whatever. And then y is constant. That's really important because if y is constant, the integrate of a constant with respect to x is just kx plus c. So, all right, so you know that. All right, so here we go. I'm integrating with respect to x. So when I integrate negative 9x with respect to x, that's just normal. So that's just negative 9x squared over 2. Plus, when I integrate 18y with respect to x, y is constant. So if I'm integrating 18y with respect to x, I just get 18y times x. And then if I integrate negative 19 with respect to x, that's still constant too. All right. So from 3 to 6. So we're going to plug in my 6 and plug in my 3. And we just have to be really careful here. So when I plug in my 6 for x, that's what I get. 6 squared is 36 over 2 is 18 times negative 9. All right, 6 squared is 13 divided by 2 times negative 9. So it's negative 162 plus, I'm plugging in for x, so 6 times 18 is plus 108 minus 19 times 6 is 114. Okay, and then minus, I'm going to plug 3 in for x. Okay, so I get 3 squared is 9 times negative 9 is negative 81 over 2. Okay, and I'm plugging 3 in for x, so 18 times 3 is 54y. And then I'm plugging 3 in for x, so it's negative 19 times 3 minus 57. Okay. All right, so probably what I would, oops, I forgot my y here. So sorry. So yeah, I knew that if I'm integrating with respect to x, everything left should have y's in it. So when I plug in 6 for x, I got 6 times 18 was 108 times y. All right, so what I might do is clean up these. I got negative 162 minus 114 is negative 276 minus, and then 54y, and then combine these terms, negative 81 divided by 2 minus 57. And they don't take decimals in this. Oddly, everything's a fraction. So go do that double arrow button right here and call it what? Negative 195 over 2. This to me is just so tedious. Okay, so then if I were really doing this problem, I'd go check it. I would, but I know you're probably like saying hurry up. 36 over 2 is 18 times negative 9. I'm gonna check it. It's 162 negative, and then 6 times 18 is plus 108y, and 19 times 6 is 114. Okay, and then 3 squared is 9, negative 81 over 2, and 9 times 18 is plus 162. No, 3 squared is 9. 9 minus 81, 18 times 3 is 54y. Okay, and then 19 times 3. All right, 57 minus 57. And then I combined negative 162 minus 114, negative 276. And then I combine negative 81 divided by 2 minus 57. I know, just bear with me. So minus 195 over 2. Okay, so now I'm going to distribute my negative. Get 108y minus 276 minus 54y plus 195 over 2. So when I combine like terms, I get 108 minus 54, which is 54y, and negative 276 plus, You can do this fraction bar if you want to, 195 over 2. And then that gives me negative 357 over 2. Okay. All right. That won't all be this ugly. I just wanted to work an ugly one. So I integrated with respect to x. I did all this tedious work. I hope I did it right. And so now I'm going to take what's left over, 54y minus 357 over 2, and I'm going to integrate it with respect to y. And what are my y limits? From 5 to 7, go with y, just like with x, or 3 to 6, okay? So 5 to 7. All right, so I'm integrating with respect to y, so it's 54y squared over 2 minus 357 over 2 times y. From 5 to 7. Okay. Okay, so here we go. F of 7 minus F of 5. So I definitely am going to do 7 store for, you can do y, but I'm going to do X. Well, let's just do y. 7 store for y and enter. I just hit the X button twice, and I have 54 divided by 2 y squared minus, I'll just like that, 357 over 2 times y. 147 over 2 minus 5 store for x and enter, and oops, what I do, 5 store for y and enter. Okay, I'm gonna go up and highlight I'm gonna look, 54 halves y squared minus 357 over 2y. Enter, enter, negative 435 over 2. And you know me, I'm not going to type anything in again. I'm going to go get that 147 over 2 and highlight it and push enter, minus, and I'm going to go get that 435 over 2, highlight it, enter, enter, and I get 291. Okay. And that's just tedious. Okay, but you can do it. We can do it. This is just like the arithmetic where we get stuck. Use your tools. Be very careful. It can be frustrating. All right, so we're going to work another one just like that. And then we're going to talk about number 3, which is a fraction, which is much easier than these, but I'm going to talk about it for a minute. So I want to end on it. So this is the integral from -2 to 1 and from 3 to 5. And I have 5x plus 3y plus 3, and I'm integrating dy dx. Okay, all right, so dy dx, so I'm going to make a rectangle about my inside. I'm going to go figure out what this is, the integral from 3 to 5 of 5x plus 3y plus 3 with respect to y. So what is that telling me? Y, I'm increasing by y, right? That's my variable term, y squared over 2, or constant times y, and x is constant. Those are just things I tell myself in my head. Okay, don't laugh. All right, so I'm increasing each term by y. So 5x is a constant, so it's 5xy plus y is with respect to y is just normal, 3y squared over 2. And then my constant 3 with respect to y is just plus 3y. Okay, that's a huge step. And from 3 to 5, so this is where I think it's, the most tedious. So I'm very visual. I'm going to take my 5 and I'm going to plug it in everywhere. There's a y. So this is 5 times 5 is 25x plus 25 times 3 is 75 over 2 plus 5 times 3 is 15. Okay, 25 times 3. And you can do it on your calculator, 25 times 3 enter, divided by 2, enter, and 37.5, but let's double arrow it to make it 75 over 2. All right, and then I'm going to plug 3 in for y. All right, so 3 times 5 is 15x, plus 3 squared is 9 times 3 is 27 over 2, plus 9. Okay. All righty. So you can work it out inside, or you can work it out. You can distribute first. It doesn't matter. Minus 15x minus 27 over 2 minus 9. So 25 minus 15, I know that's going to give me 10x. So what is 75 over 2 minus 27 over 2? So I do the numerator over denominator. You don't have to. 75 over 2 minus 27 over 2. Wouldn't it be nice if we got a whole number? Oh, yeah, it's plus 24. Make a 4. And then 15 minus 9 is plus 6. So we can call that what? 10x plus 30. Woohoo! That looks a lot nicer. Okay, so now we're going to go get my outside negative 2 to 1 and integrate this with respect to x. Negative 2 to 1. We're doing the outside, my 10x plus 30 with respect to x. So it's just normal, 6.1, 10x squared over 2 plus 30x from negative 2 to 1, f of 1 minus f of negative 2. So I'm going to do 1, store for x and enter, 5x squared plus 30x, and then enter, and I get 35 minus negative 2, store for x and enter, and I'm going to go up and highlight my antiderivative, push enter twice, and I get negative 40. And then I go up and I highlight my 35, enter, minus a negative 40. Boom, boom. And I get 75 for my answer. Shoo. Okay. All right. So almost done, almost done, almost done. Okay, we're going to talk about problem number 3. Okay. All right. So let me go find problem number 3. Okay, here it is. Double integral from 2 to 3 and from 3 to 5, and it is 5y over 3x dy dx. So it's a fraction, and sometimes fractions tend to make our butts clench, you know, and go, oh no, a fraction. But as always, I'm going back to the original rules so that you can see, okay? All right, so let's look at 6.1. And if we had a fraction, let's just say we had 5y over 3 from 3 to 5 with respect to y, okay? So when I integrate that with respect to y, what do? When I integrate, I bring my constant over, right? And then I just integrate the variable term, y squared over 2. So my antiderivative is 5y squared over 6, okay? So we're just integrating the variable term. We're bringing our constant over, integrating y squared over 2. Okay, and then when I plug in my values from 3 to 5, then this is just first the 6.1. I plug in my 5 for y, and I get 25 times 5 over 6. So I'll do that with my calculator for sure. No, I won't. This is what I'm going to do. I'm going to plug it into the top. 5 squared is 25 times 5 is 125. over 6. Even if that reduces, you don't want to reduce it. Minus 9 times 5 is 45 over 6. And see, now you're subtracting a fraction and you have a common denominator. So that's why you didn't want to reduce either of those if those would reduce. And then you just say 125 minus 45. And you get 80 over 6. And then if you wanted to reduce it, you could, but you don't have to because we don't have to simplify in Hawks. Okay, so with that in mind, let's go look at my two variable function. Okay, so anytime you have a fraction, you're going to have your y term over your x term. And you want to integrate it first with respect to y. It won't always be set up like that, but I'm going to talk about that later. So let's do our inside term, okay? And I'm going to integrate from 3 to 5, 5y over 3x with respect to y. Okay, so what does that tell me? So y is my variable term. I'm increasing by y, right? And then x is constant. And so in my fraction, when I had 5y over 3, I brought my constant over and I increased the variable term. I integrated the variable term. Let's do the same thing here, okay? So if I'm integrating with respect to y, 5 over 3x is my constant term. That's the 5 over 3x, right? Because if y is the variable term, x is constant. And I'm just going to integrate my y. That's y squared over 2. For whatever reason, with the double integrals, when you integrate with respect to y, people try to add a y up here and a y down there, but we're not doing that. We're bringing over the constant term. This is my constant term. And I'm integrating my variable term, which is y. So it's y squared over 2. And so my antiderivative is 5y squared over 6x. And I evaluate it from 3 to 5. So what am I plugging in for when I integrate it with respect to y? I'm just plugging in for y. So it's 5 times 25, which is, we know, 125 over 6x minus 9 times 5 is 45 over 6x. And we don't want to reduce anything here because we've got a common denominator. So over 6x, and then we say 125 minus 45. And we get 80 over 6x. Okay, now if you wanted to reduce that, you would say what? 80 divided by 6 is 13.333, and you call it 40 over 3, but I don't reduce because that's where I make mistakes. But now I know what? Whatever answer I got up here, I have to integrate that now from 2 to 3 with respect to x. So I am going to integrate 80 over 6x with respect to x from 2 to 3. So I have to rewrite this as 80 over 6, right? X to the negative 1, because I have to bring that x up. Okay, so what happens when I add 1 to the exponent? I get 0 divided by 0. So what is my antiderivative with respect to x? It's 80 over 6 times the ln of x from 2 to 3. Okay. Okay, so they don't take decimals, so we have to be really careful here, okay? All right, so pay close attention. All right, so I'm going to find f of 3 minus f of 2. And even if we find a fraction, a decimal, it won't turn itself into a fraction. So we have to leave it in terms of ln. So look, I'm going to take the 3 and I'm going to plug it in for x. So that's going to be 80 over 6 times the ln of 3 minus, and I'm going to take the 2 and plug it in for x, 80 over 6 ln of 2. Okay, I'm going to tell you that this answer is perfect. That's a great answer. Okay. Okay, but you cannot call that 80 over 6 ln of 1. That is that you can't subtract the arguments of the ln, and that's what a lot of people want to do, okay? But what Hawks is going to do, they're going to use this property of logarithms that says a constant times the ln of a minus the constant times the ln of b is the constant times the ln of a over b. So when they give you their answer, I just want you to know that they're using a property of logarithms. From algebra. Okay, you do not have to use it. You can put your answer in just like that, but what they'll do is they'll say 80 over 6, and they'll probably reduce it. It's the ln. When you subtract, you divide, of 3 divided by 2. Okay, and that's the answer. Or 40 over 3, ln of 3 over 2, or this. So you just have to be careful. Okay, all right. So what I'm going to tell you is that when you get these problems, Hawks always y's on top, but sometimes they have dx first. And this is so much harder to integrate with respect to x first. So this is the only problem that we might want to rewrite on our quizzes and homework and test, okay? So let me show you what that looks like. Well, okay. All right, so if I have the integral from 1 to 5 and 2 to 7, let's say, and it is what they always put the y's first. So 3y over 2x, but let's say they do dx dy. Okay. All right, so when you're looking at just this fraction problem, this is the only one we rewrite, may have to rewrite. We want to integrate the fraction problem with respect to y first, okay? So we can do that, we can rewrite it. 3y over 2x, you can't ever change that, but I can say, all right, I'm gonna integrate it with respect to y first. So if you swap these, then you have to swap these, because the integral from 1 to 5 always goes with the x's, and the integral from 7 to 2 always goes with the y's. And order doesn't matter, but if I'm gonna integrate with respect to y first, I have to put my 2 and my 7. And then my x's will get the 1 and the 5. So you see what I did? If you swap your dy and your dx, just swap these limits. Okay? All right, so now let's do it. We're going to do the inside, the integral from 2 to 7 of 3y over 2x dy is 3 over 2x, that's my constant term, and it's y squared over 2. Okay, so remember, with respect to y is my variable term, everything else is constant. I bring over my constant and I integrate my y term. Okay, all right, so I evaluate it from 2 to 7. So 7 squared times 3 It's 147 over 4x. And then 2 squared is 4 times 3 is 12 over 4x. And this is what I'm talking about. You don't want to reduce this yet because you're subtracting. You want to keep your common denominator. Okay? And then I just have to say 147 minus 12 is 135 over 4x. All right, so in this fraction, we'll always end in an ln because you're going to integrate from 1 to 5. Okay, 135 over 4x with respect to x, because that's the n, right, when I rewrote it. So it was whatever you get here from 1 to 5 with respect to x. And so I have to rewrite it because I've got to pull that x up. Right? And so when I add 1 to the exponent, what happens to the exponent? I get 0 divided by 0, so that tells me I can't use that rule 2, so I have to use my ln rule. So that's going to be 135 over 4 times the ln of the absolute value of x from 1 to 5. And the absolute value of 5 and 1 is just 5 and 1. That's why I kind of let my, what are these things called? Absolute values go. So f of 5 minus f of 1. Remember, they won't take a decimal, so you have to take the 5 and plug it in for x. 135 over 4 ln of 5 minus 135 over 4 ln of 1. And that is perfectly fine answer, or you can put it in as 135 over 4. The ln of 5 over 1 is just the ln of 5. The ln of 1 is 0. You cannot call this the ln of 4. It will be wrong. Okay, so that or this, and those are your answers. And that's the end of 8.2. And so, I mean 8.6. That's all 8.6. Okay, integrals. So what we'll do in our next video is we're going to do the same thing with derivatives. We're going to hold x constant and derivative, or, you know, take the derivative with respect to y, the derivative with respect to x. So you'll already kind of be used to this, you know, treating x as a constant and y as a variable, x as a variable, y as a constant. So anyway, as always, email me. And those of you who aren't in my class, my email is jkjones@olemiss.edu. I'm happy to take any questions from anybody. Okay. All right. That's our next to the last section. Y'all got this. And I'll see you soon. All right.